In this video, I'm going to be talking about the generator which produces musical output based on probability distributions. This is this module here. Let's zoom in. Here we have the module. It's currently playing a sound. Now, we've got two elements. One for the pitch and one for the duration. This is associated with pitch, this is associated with duration. Now, when I move this up here, I'm changing the pitch. So we can see that the height of this is associated with pitch. The height of this is associated with duration. And we can use these generators to control exactly what happens. We can even draw it if we wanted to, but we're not going to. Alright, so let's get it in a basic situation. Now, we've got a number of different probability distributions that are available to us. All of them are affected by these controls, but the controls work differently for each generator. They're labelled M and S because under the Gaussian distribution, this is the mean and the standard deviation. Currently, the mean is somewhere in the middle, and then I can introduce some variation. A little bit, a medium bit, or a lot. The same with the duration. So, by combining the two, we can say a little bit of variation in the middle, or up the top, or down below, so we can guide the musical output. The actual range of notes is determined by these mapping functions here. This will determine the lowest note, and this will be the range. Currently, the range is an octave. Let's make it 0. Everything is the same note. And I can determine what that note is by setting the lowest note. Let's make it middle C. Then I can increase the range. So down here would be middle C, up here would be C an octave higher. We're now playing somewhere in the middle. So we can control exactly what we're going to get within rough boundaries. Now there's some other distributions. There's a Poisson distribution. This one determines the bottom note and the variation. I can go faster. With a linear distribution, this doesn't do anything. It just forces it to recalculate. There are 3 linear distributions. This one here in the middle means it's a uniform distribution. That means every note is equally likely. When I go it up here, we have a high bias. More high notes than low notes. When we go down, we have a low bias. More low notes than high notes. The triangle distribution responds like that. This doesn't do anything. It just forces a recalculation. And finally, we have the exponential distribution. This will introduce the amount of variation. Now, if I want just a bit of variation, I can set it there and move the whole thing up. So this acts as a bias. So I can control it. Similarly, we have the same sort of things with our duration. More longer notes, more shorter notes. Triangle distribution. Exponential distribution. I can set the minimum length by moving that up. So that's basically how you can control this generator here, which makes use of probability distributions. So these are formal processes which have no history.